Okay, let's look at the next one. So it says find the inverse function, test the solution using x equals to 2, and then show that if you do g after the inverse of g, it should be equal to doing the inverse of g after g of x, and they should both just be x when you're done. I know that's hard to understand until you see it, so we're going to look at it now. And then that symbol there looks like kind of like a V. It's for all, just for all values of x as an element of R. That's what that means. So let's get into it. So with this, we're going to start by letting y equals to the 12 minus 4x over 3, same as we normally do. We're going to then multiply to get rid of that to keep it positive, and I'm going to bring your man back, y over 4. Now, we use function g and x. Okay, so that's our inverse function done. So that's part 1 done. Part 2, test the result using x equals to 2. So what we'll do is we'll rewrite it first. We'll g of 2. I end up with 12 minus 4 times 2 over 3. So that's 12 minus 8 over 3. And that ends up being 4 over 3, or 1 1/3. Now, if I now look at the inverse function, so again, I'll just rewrite that. So this is the inverse function for g. If what I'll do is, so I do 4 over 3. So in other words, I'm putting in my answer from the last one. So that's 12 minus, that'll end up being 12 minus 4 over 4, which is 8 over 4, which is 2. Now, the reason I'm showing you this is because if indeed it is an inverse, then I should get back the starting point if I put the answer into the inverse. So this is showing us that if we get an answer, so if we get an output from the function and we put that output in as an input to the inverse function, we get back 2. And that's how we know that it's definitely an inverse, because remember, all the operations are supposed to be opposite. So if we put 2 in and get an answer, and then put the answer into the inverse function, we should get back 2. So that's what it means by test. Because if that test doesn't work, then that's not an inverse. So if it said, if it just gave you an inverse and said, check if this is the inverse, that's how you would check it. You would put in an input, you would then put the answer into the inverse and see if it gives you back the original input. And then on that note, how do we do the next bit? So I'm going to write it out here, part 3. So I'll rewrite the question here. So there's this idea that if you do g after the inverse, or you do the inverse after g, it should give you an answer of just x when you're done. So let's see if that happens. Now, let's start with the left-hand side, g after the inverse, g after the inverse. So what that means is you're putting the inverse into the function g. So I'll write down g. So g was 12 minus 4x. G was 12 minus 4x over 3. Now that's g of x. And then the inverse function is 12 minus 3x over 4. So what we're doing is wherever we have an x in the function, we are now going to put in the place of that, this guy. So we end up with 12 minus 4, 12 minus 3x over 4, all over 3. So in other words, we are putting the inverse into g of x, okay? So wherever there was an x, I replace it with my inverse. Now, obviously, tidying up has to be done here, and that's just part of this. So it's not very pleasant looking, but it is just part of this process. So 12 minus. Now, the good news is the 4's cancel, so it's not as bad as it first seems. Minus 12 plus 3x. Please be careful there. Minus is plus. So they then cancel. So we end up with 3x over 3, and I end up with x. Now, was that supposed to happen? Well, let's go back and look at the question. It's supposed to happen that when I do this, it should equal this, and they should equal x. So that's exactly what's happened. Once I have done what I needed to do, I ended up with x. Now, I wonder, will it be the same the other way around? Well, we're about to find out. So this time round, wherever, so I'll rewrite it again. So that's my function. This is my inverse. Now this time it is putting the function into the inverse. So wherever I have an x in the inverse function, this guy should be going in. So that's going to be 12 minus 3 bracket 12. No, sorry, I've done that the wrong way around. $12 minus, oh no, it is, sorry, 12 minus 3, yeah, sorry. So that's going to be 12, and then the function is 12 minus 4x over 3, all over 4. So all I've done is replace the x. Now, obviously, again, I have to do tidying up. The 3's cancel, so again, not as bad as it might first seem. The 12's cancel, and then I'm left with 4x over 4. And the 4's cancel, and I'm left with x. So we said this at the very beginning of the notes. If the inverse is being done properly, then basically we should end up with x, because we're putting in the inverse into the function or the function into the inverse. Either way, you will end up with just x and you're done. It says state if the following functions are invertible. Give a reason for your answer in each case. So in other words, do they have an inverse? That's what that's basically asking us. Does this function have an inverse? Does it have an inverse? Okay, so I suppose the only way of knowing whether it's an inverse is it bijective? If it is bijective, then it does have an inverse. So that's what we really need to prove, that it's bijective. So let's see. So it says F is, so OR is our domain. So we're basically talking about all numbers. Now, our codomain is not quite all numbers. Our codomain says that we can go down as low as we like, but we can only go as high as 4. Okay. Now, the function itself is this. Now, it's a quadratic. Might be no harm just getting some values. So for I already know it's kind of that shape, you know, because it's a negative x squared, but it might be no harm just getting a few values. So let's say we do -2, 0, and 2, something like that. That would be 4 minus 2 squared, 4 minus 0 squared, and it would be 4 minus 2 squared. So we end up with 4 minus 4, 4 minus 0, 4 minus 4. So we'd end up with 0, 4, 0. So the couples will be -2, 0, 0, 4, and 2, 0. So if I was to plot that, -2, 0, 0, 4, and 2, 0, that's what kind of a shape we would get, which is what we predicted up there. That's kind of what we predicted. So the question is, if we do our horizontal line check, for example, there, we can see that this is touching it more than once. Okay, so this is touching it more than once. So for that reason, it is, it's not exactly once. So it is not bijective, which means it wouldn't have an inverse.